Good morning, everyone. My name is Cody James with Olympus Controls. I am our robotics sales specialist here in the Gulf region, covering North Texas, Oklahoma, North Texas, Oklahoma, Arkansas, and the border region with Mexico. And today we're going to talk about a project we did last year that we really took from concept to a completed system, and just talk about some of the processes and steps we took to go from start to finish, and talk about some of the concepts we first had, some of the hurdles that we had, and just some of the finer points of, when you're starting with robotics, how do I get to that final system? So you may have already seen this video online that may have drawn your attention. I'll go ahead and play through it real quick. So this is a system that we put together for a customer last year that we're serializing each of their parts with a laser marker and then placing them into a finished parts bin and working our way through this stack. So we go over, place our finished part after we serialize, then go grab a new part. On the back side here we have our part presentation rack, which is very important. I'll talk about that a little later. We work our way down through each of the columns, go to our laser marker, get the serial number and a QR code etched onto the part, and then we place it into the finished parts bin. One of the things to note here is the robot is the controller in the system. So from a startup procedure, an operator would interface with the robot's teach pennant, give a starting serial number, and then the robot just works its way through the stacks and communicates with the laser on what serial number we're going to be marking on those parts. And so I'm going to walk you through some of the steps we took to go from an initial concept to getting here. Just real quick, wanted to point out some of my contact information. Cody James here in the Gulf. For this system, it all starts with an initial meeting, right? We had a customer that was interested in robotics and building their own in-house knowledge, but not really sure where to start. And unfortunately, they were not starting from a blank slate. They had robotics in their facility in the past that just did not work for a variety of reasons. One, they started with a very complex application that required a lot of design and integration and was a very long lead time, and it didn't really have the right goals defined. So it was a surface prep application, and there wasn't a very good layout of how to define a good part versus a bad part, and I'll talk about that a little more later. With that first robot, and that kind of set their mentality on robotics and where they thought they could work and where they thought they just couldn't work, and that kind of left a bad taste in their mouth. So whenever they started to look at robotics again, it was through that lens of a failed robotics project. So whenever we started to look at applications that might work for them, we try to keep this in mind of what would be a good project for them to start with that we could turnkey for them, provide a complete solution, but keep it open so that they could adapt on it themselves. So continuing on, when we first started working with this customer, we evaluated a few applications with the goal of identifying one that ultimately they could own themselves and adapt themselves for future applications. So one of the first things that we do here at Olympus when we're meeting with someone is tour their facility, look at their current processes and applications, look at what their goal is for the future, and try to identify some of the best applications to meet their needs and meet their roadmap. To help identify which applications are the best and help grade, if you will, a good application versus a bad application, we'll work with something called an application matrix. And basically it's a scorecard. So that way, after we leave, you might have a meeting with your boss, or you might have a meeting with your manager, and they might say, well, why don't we start with automatic welding of the full vessel or something? With this scorecard, you can have that meeting and say, well, here's why, because it's too expensive, it would take too long to implement, and it just wouldn't be easy for us to maintain. But if we look over here at this pick and place application, it's very low cost, it's very fast to implement, and it's something that we can learn and then adapt for our future needs. So it's a much better application to start with. So with this customer, we went in, met with them, reviewed a few of the applications that they had, and just kind of graded them. So on our robotic application evaluation matrix, we had a couple. Machine tending was very common, and we see that done a lot in facilities, and it really is a great way to learn automation and learn robotics. We gave it a score of 12 just from ease of implementation, speed of deployment, but lower cost, not so much just because of the tooling that would be needed. Just from a hardware standpoint, the cost was going to be a little higher. And then we'll try to add some notes on why we gave it this score. So ultimately, we did not start with machine tending with this customer because they didn't quite have their process dialed in yet. They were running maybe 5 or 6 parts before inserts had to be changed. The robot can't change inserts inside of a CNC tool, so we decided not to go with that one. We also looked at a grinding and deburring application, and this one was actually pretty difficult. There were places that the robot would have to reach and almost do a 270-degree turn with the tool around a blind corner, and that just wasn't going to work for their application. There was also a lot of visual inspection that needed to be done, which the robot does not inherently have that ability to do, so not a good application for them to start. And that's where we landed on the automated serialization here in the middle. Fairly easy to implement because essentially it's a pick and place application with the robot telling the laser when to mark and when not to mark. Little low on the speed to deployment just because there's some design and fabrication that needed to be done, and fairly low cost. Outside of the hardware, there wasn't a whole lot of other costs associated with the system aside from programming. One of the major benefits of this system for them, kind of an intangible, if you will, was the ease of it to adapt for other parts. So knowing that their plan was to develop this in-house knowledge and to grow their own team and to be able to doing their own applications, we started with the automated serialization with the laser marker. We'd start here, teach them how the current system works, teach them how to update parameters on the laser, how to adjust settings on the robot, and then that's allowed them to make changes for future products. So if they get in a batch of smaller parts, they're able to make the changes on the robot side and the changes on the laser marker side to accommodate those new parts without us having to come in and do it. So it saves them a lot of time in part changeover and a lot of costs and not having to have a third party come out and make those changes for them. So with all those things considered, we decided to move forward with the automated serialization project. And so once we started there, we started to look at concepts. So for this customer, they wanted initially a turnkey system that they could develop on and could learn from. So from an Olympus standpoint, we said, okay, we need to start de-risking this, because initially there were a lot of things that the customer wanted that wouldn't be easy to own themselves in the end or easy to adapt for future products. One of those things would be bin picking. So initially the question arose, well, can't I just pick these parts out of the bin that they're presented in? And the answer is yes, it is possible, but for their first system, we didn't identify it as a good application. Maintaining a 3D bin picking system with an offset tool like this wouldn't be the easiest thing for them, and it would drive the cost up substantially. So we de-risked it for Olympus by saying, well, let's have a mechanical fixture to place our parts. So when you're looking at automating a system or automating an application, part presentation is key. And the way we worked around that was by having this stack location here. So an operator, a team of operators would come in, load the parts, and we timed it. It takes roughly 20 minutes to fill this stack of parts, and then about 3 hours to work through all of the parts on the robot side. So instead of picking out of the bin with a 3D vision system, which would have added cost and complexity to the system, we went with this fabricated part stack here on the backside. So what that allowed us to do is say, okay, now we go from a 3D bin picking solution down to a pick and place system, much more simple. But one of the things that we didn't have out of our Dallas office was necessarily design and fabrication capabilities. So what we did was start to de-risk the application for us and for the customer by bringing in one of our integration partners to help on the design and fabrication side. What we started with initially was the thought, okay, we'll pick from this stack, go to the laser marker and place into the bin. And initially when we presented this to the customer, everyone said, okay, this is good. They were happy with loading the parts into this stack, where we had the laser placed and where we had the bin placed. Everything looked good. So we had this system fabricated, welded, with Cobot Depot. They did a really good job. Very nice powder coat that you see in the video. The issue we ran into was reaching the farthest corners on the bin whenever we went to place. Everything else was working pretty well. We could pick everything from the stacks. We could communicate with the laser pretty easily, but just placing down into this bin was a challenge. So what we did, we worked again with Cobot Depot to design a bolt-on lift for the bin that would bolt onto the frame and provide a very nice datum for placing the bin. So what we ended up with, and that we see in the video, is this system down here. So we have the stack with the robot in the middle, the laser here in red on the right, and a bin to the back. Now, going back to importance of part placement, everything here is repeatable in terms of where it's mounted to the robot. So the stack of raw parts on the left goes into bolted on racks so that they go to the same place each time. So those are fixtured. The laser, relative to the robot, it doesn't move. So whenever we place our part below the laser, we know where the part is and we have full control over it. So the laser is always at its correct focal distance so that we get a nice clean burn. Or whenever we're placing the part in the bin, our bin is set thanks to this rack that we added on. So now everything is fixtured to the robot. So a great place to start in automation with robotics is with everything fixtured. It's lower cost because these can typically be made out of aluminum or maybe some lower cost steel, sometimes even 3D printed depending on your specific parts. And then you don't have to worry about added sensors. So yes, it is possible to account for variation in the part location with cameras or added on sensors, but when everything is bolted in place and set in place relative to the robot, it just makes programming and then program maintenance much more easier. So after we did our first testing and realized we couldn't reach the corners of the bin, we went back to the drawing board with a lot of help from Cobot Depot and ended with our final solution here of the bin placed on this rack with the rack bolted to the main structure. So what that allowed us to do was program in each of the locations in the bin for placing the parts. What this also allows you to do is overcome any variance in operator placement. So I'm sure you've all had this issue of how hard could it be to place something repeatably in the same location. It happens quite a bit. You're doing this job of feeding a machine or moving things from one box to another. Maybe you're doing it 8 hours a day. You start thinking about your bills. You start thinking about other things, and now all of a sudden I've turned something 80 degrees that's not supposed to be turned, right? Most of the time this is overcome with mechanical fixturing, as I'm sure you've done in your own applications. So we overcame that with mechanical fixturing with the racks for the parts and with this bin. So now whenever I ask an operator to go load my laser marking machine, they simply clock the parts inside of the rack and then place the bin between these rails here. So I get some tactile feedback. If I'm placing a part inside of a machine, I know I've got it in place because I feel it up against the back of the chuck, or I feel it up against or down on the vise itself. Very similar concept here. And when you look at the cost of adding in these rails, it's very, very inexpensive compared to possibly adding in a vision system. So it is possible to have a rack location without these rails to where you just tell them to put it on the table or on the bin location, and then we'll use the camera to find that bin, but it's less expensive and more repeatable just using this fixturing. So we did have to go through a redesign here to ultimately come up with something that will work, but that is kind of the one of the features of starting an automation. You're not always going to be able to know the issues or the hurdles you're going to run into. You just have to be aware that there's going to be some things you have to work through. Here we didn't necessarily know that we wouldn't be able to reach the bottom of this bin with the tooling that we had, and so then we just had a choice to make. Do we lift the bin off of the ground, or do we adjust our tool? Ultimately, we decided to lift the bin off the ground because it would offer a nice fixture for the operator to place the bin, and it would be a little easier than making the adaptations to our tool. So again, by partnering with Cobot Depot to help with this design and fabrication and then ultimately adjustment with the bin, we de-risked it for ourselves and de-risked it for the customer. So that way, whenever they received everything on site, it was ready to be bolted down, program was already developed, and there was nothing that they needed to machine or create at that point. So after we decided on this design, we had the bin brought in, we went through the final programming of the system. And as we work through it one more time, I'll kind of explain what's going on. So remember, the robot here is the controller. It's telling everything what to do. Universal Robots did a really good job of adding in a lot of functionality to their controller to allow us to do this. So I'll stop right here. The first thing we're going to do is use the built-in force torque sensor on the robot to find the top of our stack. So we come down, we use the force torque sensor, and a lot like grabbing something out of a box, right? You don't necessarily have to look into the box to find something. You can just reach down in with your eyes closed and feel it and say, oh, that's my part, and then I can grab it and pull out because you felt it with your hands. We're doing something very similar with the robot here. So we're reaching down, we're finding the top of our stack, and then we're grabbing our part. Another key thing that we're doing is we're saving that position. So the next time I go to find my next part, I don't stop at the top of, I don't start at the top of the stack and then have to go down 2 meters or however far to reach my next part. I start about an inch above my last part to go down and grab the next part. So I save myself time. Now, we could adapt this system to where it's just constantly running. So an operator could refeed these stacks if we needed to. So that way we just continuously run the machine. And in that scenario, we would start from the top of the stack or add in some kind of laser distance sensor. But for now, we just started with the robot finding the top of our stack and then saving that position. So we start there at our next iteration. So we do what's called an ID pick, where the robot grabs the middle of the part by opening the gripper. So we approach the part with the gripper closed, go in the middle, and then open, and then back out. Then we present the part to the laser. So one of the critical things to know about laser marking is your focal distance. It's the distance between the laser lens and the actual part. Most lasers on the market have a tolerance of about 5, maybe 6 millimeters. So your part presentation and distance of the part from the laser is very critical. Otherwise, you get the part out of what's called the heat affected zone, to where you're not actually burning the part or marking the part because there's just not enough heat density there. So whenever we move the part into this location, it's not very forgiving in terms of your Z, your distance from the laser. So we place this part at a very specific location relative to the front of the laser. Now what we can do, since the robot is holding the parts while it's being marked, we can easily make an adjustment for future parts. So if my next part, let's say, is a little thinner and its marking surface is maybe an inch lower, I'll simply raise this position on the robot up by an inch to bring it back into the focal point of the laser. So the laser starts to mark the part that the robot is holding. We get a nice QR code with great contrast relative to the part being marked. And once it's done, we get our finish signal back from the laser. So the robot is controlling each of these things. It's moving into position. Once it's in position, we tell the laser, hey, start marking my part. We're just hanging out there holding the part, letting the laser do its thing. Once it's done, the laser's going to tell us, hey man, you're good to go. I just marked your part. And then I'm going to go over into the bin and place my part. One thing the robot is also doing is telling the laser what to mark. So on board the robot, we have a lot of communications options that allow us to work with different products. For this specific laser, we're doing TCP/IP communications. So we'll open a communications port, send a string to the laser, and then give it the go signal, and then the laser just marks that string. So from the operator's standpoint, once the stack is loaded and they're ready to run, the robot has a pop-up that asks for the starting serial number. I would put in 00001, and then the robot simply iterates through serial numbers there. So we mark, we get our nice contrast, and then we go over to our bin and start to lay down our stack. So as you can see, these particular parts needed to each be rotated a specific way. So we saved positions for each of these parts so that the robot would be able to place all of them into the bin without colliding on the protrusions here. And then we let go of the part, come back, and grab our next part. So a couple things to mention. This was, a first run at the application. We hadn't done a system of this size, at least down here in the Gulf. The challenge for us was the design and fabrication side, again, which we de-risked by bringing in a partner that we knew was extremely capable in that portion. Again, Cobot Depot did the design and fabrication and powder coating of the materials here. Where we excelled was doing the programming of the robot and interfacing with the laser, and then also placing the parts into the bin. So now a couple ways to improve upon this. So let's say instead of running one bin at a time, maybe I wanted to run 1,000 parts, which could be multiple bins. I would need to refill these stacks. So one of the ways we could improve upon this would be to add maybe a sensor to the top of each stack, or just a sensor onto the robot itself. We could approach the stack from the top, look at our sensor to find out where the new top of the stack is, and then iterate through the stack there. That way, the robot isn't relying on the last known position of the top of the stack. It's just looking at the next top of the stack position each time. You could also then add a verifier right next to the laser. So let's say I marked my first part, but I'm not sure if the operator put in the actual serial code that I wanted. I could add a verifier onto the side of the laser here. After I mark my part, I could put it in front of my verifier to verify the code is readable and verify that it's the code that I wanted, or the serial number that I wanted, before placing it in the stack. Since the robot has communications controls and built-in logic, we can place that part into a scrap bin or into a reworked bin if we get a bad code or if we get an error. One other way that you could optimize this would be with a turntable. So let's say I always wanted the laser doing its thing because that's really the process tool in this cell. I could add like a turntable below here, and the robot would feed a raw part onto one side of the turntable and then flip it under the laser. While the laser is running, I could grab another raw part and place it onto the second location of that turntable. Once the laser is done, it rotates the finished part out, and the new raw part goes underneath the laser, and the laser immediately starts marking again. While the laser is marking, I would grab the part that just got finished, place it into the bin, and go grab another part and place it into the slot where I just removed my finished part. So we also laid those out for the customer after we delivered the system. So that way we said, hey, we didn't start with all the bells and whistles here initially because that would have increased the lead time, would have increased the cost, and then it would have increased the complexity of the first system. But when you get to a point where you want to add those in, or if you want to add those in, here's how we would do it, and we can help you make those changes. So looking at this through the lens of a first system, a first automation project for a customer that's building their own in-house knowledge, you have a really great learning platform that you're also getting an ROI out of from a production standpoint. So we were actually just working with this customer last week. They do have some new parts that they're starting to run on the cell. We gave them some information and helped walk through some of the laser changes to maybe do a deeper mark or a more shallow mark, or how to change the QR code settings that they want burned in. And they're starting to make those changes themselves. So why is that important? It's putting the control in the hands of the end user to kind of be self-sufficient. They don't have to wait for us to come on site. They don't have to exchange emails back and forth trying to schedule that time on site. They don't have to pay us to come on site. So it's very much a self-sufficiency type of system, and that's why was a good starting project for them. That's kind of the end of our Twitch. At least what I wanted to cover. So here's our contact information here. You can also go to olympus-controls.com to learn more about us and what we can provide. Feel free to reach out to us if anything comes up. All right, thank you for joining. Take care. Bye.